So as you can see, I have taken 4 questions and clubbed them together. All 4 have been asked in UGC NET 2017, and they're all on C++. So it might look a bit clumsy at first, but it's good to, solve these questions together. These are all theory questions and won't take much time. So I've decided to put all of them together so we can do as many questions as possible. So let's start with the first one. Here they've asked us, which of the following cannot be passed to a function in C++? Now, we know that we can easily pass a constant to a function. How can we pass a constant to a function? Let's say we have a function called f, and let's say we want to pass a constant called 6. So we do this way. So this is how you pass a constant to a function. How would you pass a structure to a function, an entire structure? Very simple. You define a structure variable and you pass the name of that variable to a function. So you would take f and let's say str. If str is the name of my structure variable, then I could pass it using this kind of a function call. And can I pass an array to a function? Yes, we can pass an array to a function. And how do we do that? We do that by simply using the array name. Let's say the array name is arr, then I use f of arr and an array name will be passed. An entire array will be copied. But can we pass a header file? No. A header file can never be passed using a function in C++. So which of the following cannot be passed? Mind you, cannot be passed to a function in C++? A header file. Okay. Now coming to the next one, which of the following storage classes have global visibility? Mind you, this is my key phrase, global visibility. Global visibility means the variable or the function. We mainly talk about global variables. So global variables will be visible throughout the file. That means they have file scope, and the storage class that we have for global variables is extern. Extern means external to any function or class. So which of the following storage classes have global visibility? Extern. Right? Now, I'll just touch upon the other points as well, the other options. Static variables will not have global visibility because static variables are generally defined locally. We have local static variables and they're used to retain values between function calls. What about auto? Auto storage class given to a variable ensures that variable, the variable with auto storage class, comes into existence when the function in which it is declared is invoked. And as soon as the function returns to the program or returns to another function that called it, it goes out of memory. So variables automatically come into existence and they automatically go out of scope. That's why the name auto storage class. And what about register? Generally, we would use loop control variables with storage class register because we would want our loop control variables to execute as fast as possible. So small valued variables which you want to execute at as fast a rate as possible, you would use the register storage class. Generally, loop control variables are used with the register storage class. Now, the next question is, which of the following operators cannot be overloaded in C++? Now, remember, the operators that cannot be overloaded in C++ are 6 in number. And what are those 6 operators? Those 6 operators are the conditional operator, the scope resolution operator, the type ID operator, the size of operator, the member selection operator, and the member selection with pointer to member operator. Now, out of these 6, we find only structure reference to be present in this list. So, this operator cannot be overloaded. So, the structure reference operator cannot be overloaded. Sorry for the inconvenience. Just get it right. So, the structure dereference operator cannot be overloaded. I hope this is visible to everyone. Now coming to the next one and the last question, choose the correct option with respect to function overloading. What is function overloading? Function overloading refers to having one name for a function, having one name for multiple functions and using them to carry out different tasks based on the number of arguments, the type of arguments, or both number and type of arguments. So function overloading is a way to implement polymorphism in C++ and as well as in object-oriented programming in general. So they've given 4 options and they've asked us to choose the correct one with respect to function overloading. So what are the options? The first one is separate function setup for every function definition. Yes, so in function overloading, the overloaded functions, for each of the overloaded functions, the compiler sets up a separate function definition. So this is definitely correct. What about option B? Separate function not set up. No, this is not correct. What about the third one? Cannot handle different types of objects. Mind you, function overloading is done with respect to 2 parameters. The first one is the number of arguments and the type of arguments. And if you're able to have different number of arguments as well as different types of arguments, even better. So function overloading, now these arguments in function overloading or in overloaded functions can be of type objects as well. So this option is not correct. That function overloading cannot handle different types of objects? No. Function overloading can handle different types of objects. And what about the last one? The last one tells us that function overloading cannot have same number of arguments. Even this option is incorrect because functions overloaded can have same number of arguments provided those arguments are different in terms of their data types. So this option is incorrect as well. So out of these 4 options, only option A is correct with respect to function overloading. And this was option D, mind you. Thank you.